Hello, fifth graders. Welcome to our math concept review video. So this is the order in which I'm going to review our concepts. First, we'll review fractions and the operations involved with fractions, then decimals. After that, just basic operations, which are adding, subtracting, multiplying, and dividing. And last, a word problem strategy that you can use, okay? So first, let's review fractions. So a fraction is a numerator or parts over a denominator, which is the whole, okay? So fractions are parts of numbers. A fraction that has 1 in the numerator is called a unit fraction. A fraction that has a larger numerator than denominator is called an improper fraction, and it's bigger than 1. It's bigger than 1 because you have more parts than the whole. So if I have a pizza cut into 4 slices and I have 5 slices, that means that I have an extra fourth. So I have more than 1 whole pizza. Okay? Let's start working with this just a little bit. Here I have a pizza, or whatever it is you want to say that I cut up. It's cut into 1, 2, 3, 4, 5, 6 pieces. So 6 is our whole, so that's our denominator. The amount of parts we have are 2. So it's 2/6. This picture is the fraction 2/6. Now when we're talking about fractions, we can simplify them by creating equivalent fractions. The way that we do that is by either multiplying the numerator and the denominator by the same number, or dividing the numerator and the denominator by the same number. Now when I look at 2 and 6, I think, is there a number that I can divide both 6 and 2 by? And I know 2 can be divided by 2, and so can 6. So what I'm doing is I'm dividing 2 from the numerator and 2 from the denominator. So I'm going to make an equivalent fraction of 1/3. That means that this piece here, if this was one piece, and there were 3 total pieces, 1/3 is equivalent to 2/6. So if you have 1/3 of a pizza and 2/6 of a pizza, it's the same amount. It's just less parts, so they're bigger, okay? So if I take 1/3, which as you will recall is a unit fraction, but because it has 1 in the numerator, I can create many equivalent fractions. So I know that I changed 2/6 into 1/3 by dividing by 2. So if I wanted to change it back, I could multiply it by 2 and get 2/6. I can continue this fraction chain going by taking 1/3 and then multiplying it by 3. 1 times 3 is 3. 3 times 3 is 9. And we can go another time. It's important that you always start with the unit fraction. So then I can multiply it times 4. 3 times 4 is 12. 1 times 4 is 4. So 1/3, 2/6, 3/9, and 4/12 are all equivalent fractions. They mean the same amount. Let's move down here. So if you could now copy this down onto your paper, or you might be able to do these in your head. So we have 1/3 plus 1/3 equals, and then 3/4 plus 1/4 equals. If at any point you want to pause the video in order to copy down the numbers, you should do that. So when we're adding fractions with a common denominator, that's what we call it when it has the same denominator. The denominator stays the same because that's how big that's how many pieces we have. That's our whole, okay? The whole doesn't change. But we're going to put the parts together. So, it looks like a face. So you add the numerators and the denominator stays the same. So if I take 1/3 of a pizza and I add it to another 1/3, I have 2/3. Okay, try this with fourths now. Pause if you have to. Fourths is our whole that stays the same. We're going to add our parts together. Now, when we're thinking about fractions, we have to make sure they're in their final form. So when you look at 4/4, think about it. If you have 4 total pieces, that's your whole, and you have all 4 of them, you really have one whole. Another way you could do that is fractions are really just a division problem. So this bar right here, the fraction bar, really means divide. 4 divided by 4. Let's see. What is 4 divided by 4? 4 can go into 4 one time, and anything divided by itself is 1. So 1 would be our final form. 7/2, as we just talked about, when the numerator is greater than the denominator, that is called an improper fraction because it is greater than one whole. Okay? So we need to convert this into something called a mixed number, which means it has a whole number and a fraction part. In order to do that, you need to think, how many times can 7, or I'm sorry, I misspoke. How many times can 2 go into 7, or what is 7 divided by 2? Well, I'm going to skip count by 2s and see how close to 7 I can get. 2, 4, 6, 8, nope. So 3 times gets me to 6. So I have 3 wholes. 3 times gets me to 6. When I subtract, I have 1. There's 1 piece left. I got to 6. I didn't get all the way to 7. So there's 1 piece left. What size are our pieces? Halves. So we have 1/2 left. So 3 and 1/2 is the same thing as 7/2. Take a minute to pause the video. Copy these down, please. 3/5 plus 2/7, 9/10 plus 2/5, 1/2 minus 1/3. As you're copying these down, you should notice that the denominators are different. Okay, after you've paused. So in order to add and subtract fractions, you have to have a common denominator. And it has to be the least common denominator in order for your fraction to be in its simplest form. So when I think about 5 and 7, I need to find the least number that they have in common. So you should skip count by 5s and 7, and then choose the number that they both share. That's the smallest. So for 5s, I have 5, 10, 15, 20, 25, 30, 35. When I skip count by 7s, 7, 14, 21, 28, 35. So 35 will be my common denominator. We multiplied 5 times 7, so 3 times 7 is 21. We multiplied 7 times 5, so 7. So 5 times 2 is 10. Denominator stays the same. 21 plus 10 is 31, and that's our final form. Okay? Copy these ones down. These ones, 10 is our common denominator. So I have to change my 2/5 into the equivalent fraction of tenths. When I add these together, I'm going to get 13/10, which is an improper fraction. 10 can go into 13 once, and I have 3/10 left over. 1/2 minus 1/3, our common denominator is 6. Pause the video and try to solve this. Once you've solved it, unpause the video for the solution. Oops. Oopsies. All right. Last one for fractions. Multiplying fractions. When we multiply fractions, we do not need a common denominator. Also, when you see the word of, that means multiply. So we could also read these problems as 3/5 of 1/2, or 1 4/7 of 4 1/5. So our rule for multiplying, copy these down and pause, try them on your own. Our rule for multiplying is we see if we can simplify first. So we make an X with our eyes and see if we can simplify. We can't. So we multiply straight across our numerators and denominators. Check to see if I can simplify. I can't. That's my answer. In order to multiply, you have to multiply them as one fraction each. These are mixed numbers, so we need to turn them into improper fractions. The quick way to do that, in order to figure out how many parts there are, you go around your fraction. 7 times 1 is 7, plus 4 is 11. So we have 11 parts out of our 7 whole. Times, we do the same thing over here. Denominator times our whole number. 5 times 4 is 20, plus 1 is 21. So we have 11/7 times 21/5. Next, I'm going to make an X with my eyes and see if I can simplify. 11 and 5 are prime numbers. They can only be multiplied by themselves in 1. So those we're not going to be able to divide. But 7 and 21, when I skip count by 7s, I say 21. So divided by 7, 1. Divided by 7 is 3. We'll multiply across. 11 times 3 is 33. 1 times 5 is 5. Now you either have to do 33 divided by 5, or count how many times 5 can go into 33. 5 can go into 33 6 times, which gets us to 30. We have 3 left. So we have 6, and then we have 3/5 left. And our last fractions concept. To divide by a fraction, here's a tip. I wish this glare wasn't here. Ooh. To divide by a fraction, here's a tip. Keep, change, flip. Okay? 4 divided by 1/2. So it wants to know how many 1/2 parts are in 4. 4 divided by 1/2. I think I might have misspoke. 4 divided by 1/2. So how many 1/2 parts are in 4? When you divide by a fraction, your answer is going to get larger. Keep, change, flip. Now when we multiply across, you can always put a 1 under a whole number because anything divided by 1 is itself. 4 times 2 is 8. 1 times 1 is 1. Anything divided by 1 is itself. So that means in 4, there are 8 1/2 pieces. So if I have 4 pizzas and they're each split in half, if I were to count these halves, I have 1, 2, 3, 4, 5, 6, 7, 8. Okay? Last one. To divide by a fraction, here's a tip. Keep, change, flip. Pause and solve. All right, now we see if we can simplify. 4 and 1, can't simplify those. 9 and 6 can both be divided by 3. And then we multiply across. That is an improper fraction. 3 can go into 8. 3, 6, 9, twice. And I have 2 left over. Awesome, that's it. So decimals and fractions are the same things. They are parts of numbers. They're not wholes, they're parts. So decimals and fractions can mean the same amount. So first let's go over our place values. So we have our 1s and our 10s. When we go this way, we get 10 times bigger. When we go this way, we get 10 times smaller, okay? So this is our tenths, so this is 1/10. This is hundredths. This is our thousandths, okay? In order to create equivalent decimals, we can add zeros to the right of our digits. So 0.7 or 7/10 is equivalent to 0.70 or 70 hundredths. And the reason it is because 7 divided by 10, okay, here's our whole number. It has to get 10 times smaller, so it becomes 0.7. Now I have 70. It has to get 100 times smaller, so that's 2 shifts to the right, so it's 0.7. 0.7 and 0.70 are the same because this 0 does not change the value, okay? Now, adding and subtracting decimals is pretty easy. You just have to, so in order to add and subtract decimals, you have to line up the place values. So think about your ones, your tenths, your hundredths, your thousandths, and your place values going this way. You have to line them up so that they're lined up. Then you bring down your decimal in the same spot. So if you have 3.2 plus 4.22, I add them. I can put a placeholder here. 2, 4, 7. I bring down my decimal in the same spot. Okay? You can copy these down and try them. Pause the video, copy them down, try them. Go. Pause. Okay, so when we add these, it's much easier to add them vertically. I lined up my place values and I put up some place value holders in. 2 plus 0 is 2. 1 plus 0 is 1. 9 plus 0 is 9. I bring down my decimal in the same spot. 0 plus 1 is 1. So 1.912. When we subtract, I'm going to just use this because it's already written here. And I am going to line up my decimal places. I need some placeholders, and now I'm going to subtract. You have to do some regrouping with this one. Bring down your decimal. So then we get 200.71 or 271 thousandths. I mean hundredths. I'm sorry, I misspoke. Now, in order to multiply, you multiply like normal, then count your decimal places, and you put the same amount of decimal places into your answer. You'll notice that the place values aren't lined up, but the numbers are. So first, you're going to ignore the decimals and multiply. So pause and do this math. It's 0.12 times 4.1. All right, we multiply like normal. We start in our ones. 1 times 2 is 2. 1 times 1 is 1. I can ignore this 0, or I can do it. 1 times 0 is 0. I need a place value holder here because I'm shifting to my other place value. 4 times 2 is 8. 4 times 1 is 4. 4 times 0 is 0. Now I add. 2, 9, 4, 0. Now I look at my place values. Up here I have 1, 2. Here I have 1. So I need a total of 3 in my answer. Start at the whole number and shift in. 1, 2, 3. There's my answer. All right. And last, we will do the division with decimals. So the deal with dividing with decimals is you are allowed to have a decimal in your dividend. You are not allowed to have one in your divisor. So this is our dividend. This is our divisor. You can have a decimal in here. You can't have 1 out here. So say I was doing 5.5 divided by 11. So 5 and 5/10 divided by 11. When you have a decimal under the house, you bring it on top of the house in the same spot, and then you divide. 11 can't go into 5, so I'm going to put a 0. You could also put an X. 11 can go into 55. I know that fast fact. It goes in 5 times. 11 times 5 is 55. I subtract, I get 0. My answer is not 5 because I remembered to bring up my decimal point. My answer is 5/10. And the way to check your answer would be to do 11 times 5/10, which would get us 55. Then we add 1 decimal place, and it gets us that 5.5. Okay? If you have a decimal place in your divisor, so say you have 0.4 as your divisor, and you're splitting up the number (24/100). So I'm doing 24/100 divided by 4/10. You can pause the video and copy this down if you know how to answer it, or stay with me. You have to shift your divisor in order to make it a whole number. Okay? So in order to do that, I need to make it 10 times bigger. So it's like multiplying it by 10. Then I have my whole number. Whatever you do to the divisor, you have to do to the dividend. I made this 10 times bigger. I need to make this number 10 times larger. So then I move in my decimal point, and it becomes 2 and 4/10. So it's like creating equivalent fractions. Whatever I did to the divisor, I did to the dividend. I shifted. It means the same thing. It's just now you can divide it. I'm going to bring up my decimal on top of the house. My answer is 0.6. The way to check that would be to use the inverse operation of multiplication. All right, now for just some basic operation review. Multiplication and division are inverse operations. That means that one undoes the other. So if I do 4 times 6, hopefully you can say, oh, I know that that's 24. Then, if we wanted to use division, we could work backwards and take 24 and divide it by 4 or 6. And get the same answer. Okay? And then say I have division first. So say I do, let's say, 240 divided by 4. 4 can't go into 2. 4 goes into 24 6 times. I have an extra 0. I'm going to bring it up. In order to check this with multiplication, I would take my answer or my quotient and multiply it times my divisor. When I do 60 times 4, I get 240. Sorry, that was out of range. I get 240. So they're inverse operations. The same way that addition and subtraction are inverse operations. So if I do 5 minus 2, I get 3. I can then add up and say, okay, 3 plus 2 equals 5. Okay? When you are multiplying a number, say you are multiplying 300 times 60, a strategy in order to do this quicker is to do your fast fact and then add your zeros. So my fast fact, 6 times 3 is 18, and I have to add 1, 2, 3 zeros. 18,000. You could do this out with your regular algorithm, but this is faster. Another way you could do this is to say, okay, 50 times 40. Fast fact, 5 times 4 is 20. I missed 2 zeros, 1, 2. So I have to add those 2 zeros. We can't get confused here because 20 had a 0 in it. You have to still add the 2 zeros. This works the same with division. Say I had 250 divided by 5. Well, my fast fact, I know 25 divided by 5 is 5. I ignored a 0, so I bring my 0 up. So that's a way that you can do those quicker in your head. And last, our strategy for solving word problems. It's an annotation strategy. Annotation is when you mark up a piece of writing. So in order to solve, you circle the numbers in the word problem, you underline the question, you box keywords like the word of, you write an equation. An equation would be like 5 minus 2 equals 3, and then you solve it. All right, thank you for joining us.